All right, let's go ahead and get started here. So, welcome to the Skill Me Up Expert Talk on Serverless Solutions. My name is Brian, and I'll be your presenter for today. Now, I've been working in .NET since it was released to beta in 2001, so I've been around for a while. I've been in various web development positions throughout my career. I've worked with all the tech stacks along the way, including ASP.NET 1 and 2, web forms, MVC, and now I'm looking into both MVC and Razor pages as .NET has continued to evolve, and we know that .NET 5 is coming up, and I'm actually doing a talk on .NET 5 in just a couple more days, so hopefully you'll be able to join me for that as well. Now, in addition to developing web solutions for many different companies, I've also been doing some teaching at the computer science department at Franklin University. I've been doing that for just over 10 years and also have developed training courses and done live training since about 2013. So I've been doing training for quite some time, really enjoy just taking people through material. And I currently hold a bachelor's degree in computer science from Iowa State and a master's of science computer information systems from the University of Phoenix. And I've earned a few certifications along the way from Microsoft, as well as the MCT certification. So you see there my Twitter and my LinkedIn. I would love to connect with you on both. So please feel free to follow me, or I usually follow back immediately on Twitter, and also connect. I'm an open networker on LinkedIn, and I would love to connect with you to have the channels open for communication, even outside of the Skill Me Up community. All right, so today what we're going to do is take a look at a number of technologies and platforms that are available for serverless development at Azure. Now we'll start by having a brief discussion on the serverless development. We'll start by having a brief discussion of serverless development, and we'll dive into the platform as a service concept. Now, after we've set that baseline, what we'll do is we'll talk about some of the more prevalent platform as a service offerings that are available to you at Azure. And we'll take a time to look at both relational and non-relational databases that are offered, as well as storage, app services for web and Azure Functions, and discuss how things like the API management can be a critical tool in your serverless toolbox. We'll take a brief look at Event Hub, Event Grid, and ServiceBus and see how those can be used in your serverless solutions for both event and messaging solutions. And we'll touch a bit on Logic Apps as well. Now, one important note to keep in mind throughout all of this is that at Skill Me Up, we have labs and videos available on all of these technologies. So if you see something in this overview that piques your interest or something that you want to learn more about, please look into this on Skill Me Up. Either look into our challenges, our videos, our labs, or definitely reach out to us in the Skill Me Up community on Teams, because we're live there and we'll talk directly with you about anything that you have questions about. And we'd love to hear from you. All right, so let's start out by taking a look at serverless development and see what's available as far as what serverless development does for us and the concepts and benefits of working with serverless development. So the entire idea of serverless development isn't really to get rid of a server. It's really just you transferring some of that ownership elsewhere. So there really is no cloud. It's just someone else's computer is completely true. That's saying that you've probably seen on a bumper sticker or a t-shirt. Really what we're doing though is we're saying, I want to start working with a serverless mindset, and then I'm going to delegate a lot of the work that I used to have to do as an IT shop over to Azure and let them handle some of that behind the scenes infrastructure work. So with serverless, you don't have to worry about networking infrastructure like VMs or servers. You don't have to worry about taking backups, recovery plans, or even worry about licensing for tools and operating systems, because all of that's going to be handled by the platform. So all of those traditional capital expenditures are taken care of by the platforms you use at Azure. Now, instead, what you can do is start small. You avoid the large upfront costs. Additionally, you don't have to know right away how much demand will be placed on your system, which is a huge benefit, because with that, what you can do is with the serverless development, you can easily start very small and pay very little to test out your concepts and prove out concepts. Now, once your app or solution is more popular, or once you start actually driving more of your enterprise traffic to that solution, you can scale your instances both in and out or up and down. And so there is a difference between those, and we'll talk about those a little bit briefly. So if there's a peak like the holiday shopping that happens after Thanksgiving, and you're supporting traffic for an e-commerce site, you can ramp up your solution. You can use that time to ramp up to multiple servers or instances at Azure, and that's called scaling out. So if there's not a lot of traffic increase, but suddenly you have a large demand on resources for your app, what you can actually do is scale your instances up with memory, disk, and other compute power. And what that does is gives you a scale in and out. So up or down is getting more machines or getting more infrastructure in place. In and out is more compute power. It's a simple way to keep them separate. Now, of course, as demand drops back down or as demand rises, you have rules in place on your platform which allow your solutions to auto scale both up and down or in and out. And that way you don't even have to manage it. It just knows if certain events are triggered because traffic demand has increased past a threshold for a certain amount of time, it will scale up or scale out depending on how you want to approach that. So in addition to the benefits of being able to easily respond to demand, with serverless development, you'll be creating a much more efficient delivery pipeline and development process. Now, in this new ecosystem, you won't have a monolith that needs days or weeks of planning, large development and testing cycles, and then deployment gates that take days or weeks to get through. With small serverless instances, developers can generally do work quickly. And if you have your pipelines automated with testing and other code quality tools, a few approval gates might still be needed, but you could see a drastically reduced lead time, which means that you can get your developers working and you can get your implementations done much more quickly with a serverless concept than you would do with a traditional monolith. Now, certainly your developers will have much more confidence as they go about making changes, knowing that this change didn't break something in the legacy code that we didn't even know existed. And I'm sure you've all encountered that situation working with large monolithic systems and you try to make a change and you're just not quite sure if you should push to production because what if with a serverless solution, you're basically getting isolated little silos that you don't have to worry about that as much. So as you start moving into serverless, where should you actually start when you're actually going to start working in the serverless development environment? So really, with everything you do, it's always going to be up to you. So you need to talk with your team, figure out what do you want? What are you trying to accomplish? Do you have something going on that might position itself away from traditional on-premises development into a serverless environment? So a good strategy is to make sure you start small and prove out your ideas. You want to do that to make sure that you can get the buy-in on that type of development because it might take some time and it might take some discussion. But if you can do something simple that proves a value, it will definitely increase your likelihood that the management team or your organization or even other developers will be able to buy in and get on board with that solution. And once they see the benefit, if you can prove it to them, if you can prove that the solution is flexible and powerful and robust, that should go a long way in helping to make the decision. So again, start small, make sure that you're not spending a lot of money up front, prove out the idea, get buy-in, and that gets you going. So looking for opportunities to make this work might lead you to find things like third-party integrations. For example, working on a real-world solution a while back, I had an opportunity that we needed to bring in a third-party API. Now, this API provided information, and we could have brought information into our database, but by doing that, we would then have to manage that database information as well, where we would have to essentially run all kinds of jobs to keep this updated. It was volatile information that changed very frequently, at least daily, sometimes hourly. And so doing that was not going to be very efficient for us as a company. So what we decided to do was take an approach where we built out a serverless solution and we were able to get the API called and get information that we needed as needed by the client. And we were able to do that in a way that was efficient and cost effective. And it didn't take any database storage on our side up front. We did end up transforming the data and using it, of course, but you can see that that would give you a powerful way to keep your solution accurate and easy to implement and update because that one piece was now siloed. We didn't have it in the monolith. It can now be easily affected and tweaked as we wanted to. So other places you might be able to see quick results with large gains might be things like services that traditionally required a Windows service being deployed to a web server or a server to run cron jobs or background jobs. Maybe sending emails off to people on alerts. Other simple tasks you could take a few weeks to develop, you might be up and running in a day with a Logic App or an Azure function. You can tie that solution in with storage or events or messages to make sure that your system is robust and talking to itself the way it needs to. Another extremely interesting place that you should look into for working with serverless development is the cognitive services space. Now, obviously, this is new to a lot of us, and it is very powerful and very interesting. There are a lot of things that you can do with computer vision or bots that we just couldn't do 5, 10 years ago. And Azure has provided platforms for a lot of these different possible solutions, and you can easily integrate them into your serverless workflow. So these are certainly worth looking into. It can be implemented much more quickly through the tools at Azure and can give you some really powerful things that you can do for your users. So as we mentioned earlier, you're delegating your server work to Azure. So how does that work? Well, Azure provides a number of platform as a solution options for you to leverage. So what we're going to do for the rest of this talk is take a look at a few of these. But first, I want to take a moment to dive deeper into what the platform as a service actually is. And so here we see just some simple platform as a service offerings that are available at Azure. Now, these are not an all-inclusive list. You see the https azure.microsoft.com, english.us/services. There is a robust list of things that are available there. But some of the key players that you're going to likely encounter, especially as a developer, is some of these key players are going to be the Azure Kubernetes service, the Azure App Service, working with relational and non-relational databases. You're going to obviously be working with storage. There's functions and functions as a service, which is interesting. The API management tool, which is extremely powerful. We'll talk about this a little bit later. Event Hub, Event Grid, ServiceBus. You can see there's quite a few there. But what we're trying to see here is that the main idea is that whatever your flavor of implementation is, however you want to go about it, Azure does have something to provide you on the platform side. And when you leverage these platforms, you're delegating work away from your responsibility. So the image here shows that you have the ability to focus in on your application and development efforts while not having to worry about the underlying infrastructure. And you should know and understand that all of that is still there. As we said, there's still a computer somewhere. There's still a server somewhere. It's just that you don't have to worry about it anymore. Now, Azure provides disaster recovery for you through multiple regions and zones, so your sites or solutions achieve what we call 4 nines or better. 4 nines is 99.99% availability. That's just about every offering. Most of them are much more than that, and you can also, configure ways to get better than 4 nines if you need it. So it's a very highly available service for almost every single one of these platforms automatically, and you can tweak them to do even better sometimes. So additionally, platforms like SQL Server often offer you things like automated backups, so you don't have to worry about that. Every platform removes any responsibility from you for worrying about server upgrades, hardware failures, and even licensing concerns. One final note is that security is also handled for you. Simple point-and-click solutions allow for prevention of direct denial of service attacks. Building physical security is also handled, so you don't have to worry about manning the doors or who has access to the key card to get into the server room, because Microsoft's taking care of all that for you. So also there's a tool that you can use called Azure Security Center that will let you know if anything you do or provision at Azure has some configuration issues or needs to be addressed for some security concerns. Now, this can often be remedied by simply pressing a button that says something like apply this remediation without you having to do a lot of work. And it'll tell you what it's going to do. If you want to go about it manually, of course you can, but a lot of times you can simply press a button and Azure will handle the work behind the scenes for you. So in a serverless environment with platform as a service, you can truly focus on building the solutions that help your customers and not have to worry about the underlying architecture as much. All right, so any transactional development effort is going to require a good relational database. And of course, Azure offers you a few choices here, which might be surprising because you might actually be surprised that in addition to SQL Server, Azure does offer other solutions like Postgre, MySQL, MariaDB, but also sometimes even recommends them depending on what you're trying to do. Of course, you can go with the normal Azure SQL database, which just lets you set up a server and instance that you can scale to meet your compute needs. But if you need more control, there's actually a thing called the SQL Server Managed Instance. This lets you have a lot more control over the solution and even a little bit control over the implementation. So with a managed instance, you can do a lift and shift of your current solutions and rely on the ability to do things like link servers, which you can't do with the course of platform as a service. So the managed instance gives you more tools like that. So if you need multiple servers that are connected like you would do on-prem, you would have linked servers. You could do that with the managed instance. You can also kick off your own backups with a managed instance, whereas with the normal SQL Server, you're basically at Azure's just taking care of all the backups for you, which is great if you don't want to mess around with that. So now, if you don't want to use Azure SQL, you might opt for PostgreSQL or MySQL with MariaDB. Now, in these instances, you can be up and running quickly, just like with the Azure SQL database. Their platforms as a services have all the stuff that you would need to run a general implementation. And essentially, any command that you would want to use that's not harmful to the OS would be available to you. So there is some caveat, because there are some features of each of these, the open source databases, that basically you don't get access to at Azure. And so if you can think about that, it's any command that would harm the underlying operating system, it has to be locked down in order to prevent unwanted consequences at Azure. So a few things like some extensions at Postgre, some procedure commands won't be available to you, so that you can't use them because of the way that they might affect the underlying architecture. So unless you're used to running deep level scripts on Postgre or MySQL MariaDB, this probably doesn't even affect you, and they would be just as robust and awesome of a solution for you as an Azure SQL database. So you should weigh, depending on your tech stack and everything, cost and compute and everything that you want to do against all three types of the databases. So the backbone of any solution is going to be storage, and you're going to be using storage at Azure for just about everything. So it lets you get and serve files. You can store disks if you're making virtual machines, but it can also be used to store things like a simple key value pair in an Azure table. So generally, there are 4 different types of Azure storage that you could create within an Azure Storage account. So you create the account and you provision these features. So for example, you might spin up blob storage container, and you could use that to host images for your web solution. Potentially, you could take uploads from your users. File shares within the Azure storage can be used just like a typical network attached storage would have been used in the past on premises. Now, this can be useful for your lift and shift solutions as well, especially if they previously required a file share for some reason. Table storage that's available at Azure is in the storage space is a lightweight NoSQL implementation that lets you store key value pairs. While this is not as robust as the Cosmos DB offerings that we have at Azure for our typical NoSQL databases, it can be a great choice for a few application level settings like user configurations, for example, on your website. Storage queues within Azure provide a messaging solution for your work. So the one thing about this is they can handle a lot of information. There's a massive amount of storage queue information available to you, but you need to make sure that you only use this if you do not care about the order of the messages, because there is no ordering. It's basically just, here's the dump of messages. So if you need ordering, we'll present a different solution for messaging in the future here in this talk. So moving into some actual development, the web solutions, if you're going to use web solutions or function apps, the backbone of these offerings is going to be the Azure App Service. And each Azure App Service lives in an App Service plan. So App Service plans determine the compute power and resilience of your application. You can start with a free tier, which gets you a chance to keep costs low and experiment, which is awesome. But as you go to the higher plans, you can add in features, or you get more features like development slots or deployment slots that you can use to quickly deploy to staging. And when you're making sure everything's working, you push a button and it swaps to production. And that's pretty powerful. You can also get more compute power, which means you can have more instances running in parallel. So the app service plan itself can host multiple app services. And so what you need to remember, though, is if you do that, all the app services within that plan will share resources. So if you're having a lot of web traffic on one of them, it might dominate that plan's compute power, and the other ones would basically pay a performance price. So this leads you to solutions like putting all of your dev test instances in one plan and production in another, so that you make sure your production is powerful, but you're not paying a lot for all your developers, right? They're all going to share those resources. Another thing you might do is have production and staging in one powerful app service with smaller dev test instances in their own plan. So each developer gets their own, maybe a free tier or a very basic tier. But then you also have potential to share a few instances for your test and your UAT. The App Service Web Plan lets you quickly and easily publish a website, whether you're using traditional .NET or other languages like Java or PHP. So this isn't just for .NET developers, it's for everyone. You define your language of choice at the plan level. So when you're creating your app service plan, you say, I want to use Java or I want to use .NET. And then Azure does all the rest of the work for configuring your server. So that's really awesome. You don't have to spend a lot of time messing around with how that's configured and what else implemented. It's going to get taken care of for you. Now, an extremely interesting serverless technology is the consumption plan, which is available for functions, for Azure Functions. And with that consumption plan, you host your Azure Functions at Azure, but you only pay for the traffic that goes to these plans in a small storage space. So you basically have to have storage in order for things to work. Like I said, you're going to be using a lot of storage, but it's very inexpensive. It's extremely, it's well paid. I'm sorry. It is very efficient, and so you don't have to pay a lot to store them. But what happens is, as you spin up your Azure Functions, they're available. And so if people start hitting them more and more, then you'll pay more. Now that could be very lucrative for you because you can quickly and easily test some new functionality and you don't have to spend a lot of money to prove it out. Hey, this works. I put this Azure function out here and all of a sudden everything's working. Now let's deploy it to the public and then pay the costs, right? So that's really great. So as we talked about that a little bit, one of the more powerful serverless tools that you do have available as a developer is going to be the Azure Functions. Now, with the ability to write your code, not just in C#, you have Java, JavaScript, or Python as well. There really are offerings for just about every type of developer that's out there. And one major benefit of Azure Functions is definitely the fact that you can get up and running quickly. With a few minutes of programming, you can build your function, you can build the function app, deploy that code and solution to the cloud very quickly. You can right-click, publish, and it's done. You can set up DevOps, have it be in a pipeline within a few minutes. Basically every change is going into your environment. It's pretty awesome. Now, once the solution is deployed, you have a public-facing API that's available as needed. You don't have to do anything else except for, of course, tell people what the URL is, and people can start hitting your functions. So you can lock the functions down, though, because that might lead you to the concern of, well, if anybody can hit my function, that's not very secure. So you can set functions so that they run only with authenticated Active Directory users from Azure Active Directory. And once you do that, you will have to have authentication tokens passed with your request, or you can set up a service that connects, such as the API management tool. Now, once you do this, anyone who doesn't have that token, any unauthorized users, will get a 401 when they hit your when they hit your function. If you just need a little bit of security but don't care about setting all that up, there actually is different levels of security you can create at each function. The first one is anonymous, which lets anybody in, and the second one that we're going to mention here is going to be the function authentication. So with that, what happens is you get a function token that each specific function has a different token that needs to be passed as part of either the query string or the header to actually execute the function. So it's a little bit of security, but just keep in mind that this function token is the same for all users. So it's not robust as a full solution. And if you have a user who doesn't like you and they share it on the internet, it would be immediately ineffective to keep your request secure because anybody who had that token and the URL would be able to run your function. There's no authentication happening in that case. Additionally, Azure Functions offers an offering called Durable Functions, and Durable Functions use orchestrators and durable entities. And what happens is this allows you to build out some robust in-memory solutions that actually live past the life of the function execution. So functions by default time out at 5 minutes. So you want to make sure to keep your functions running short and efficiently. But with a durable function or durable entity with orchestration, you can actually have some in-memory stuff happening behind the scenes that stays outside of the life cycle of the actual function execution, which is really awesome. Because a good example of this could be a solution that needs to keep track of users' choices for their shopping cart, for example. Now, it can be stored as unique to the user very easily, and if they come back a few hours or days later, their cart would still be in memory, and you could still execute functions against that cart data and have it available for the users to be working against it as if it was there the whole time. The functions can be executed or triggered in a number of ways, and what this does is gives you common execution methods like the HTTP request, which you can do from Postman or you can do from other solutions in your systems, basically making, invoke web requests and hit your Azure Functions. Additionally, you can set them up to run on triggers you can set them up to run as a scheduled or recurrence that basically runs on a timed event or a few times. And you can also respond to events from the event grid. So that's really cool. You can subscribe from the events, and the events are published in Event Grid, and your function executes as it's told to. So when it comes to creating microservices that you can leverage in your So when it comes to creating microservices that you can leverage in your operations, Azure Functions should definitely be something that you look at as your first stop. So we just talked about Azure Functions, and they're great, but as we mentioned earlier, there isn't a lot of security around them. When we talked about tokens getting shared, there's also some other problems that could happen, like people being bad players. So what we see is that without the security around them, we don't really have a robust solution for multiple clients. We don't have various API offerings that we can make as an organization that's all kind of conglomerated in one place. Well, what we can do then is use a tool called API management. This comes in and basically provides us that front end and security that we're going to need. So API management is a solid solution that allows you to build out your robust API solutions to offer your clients. In the past, you might have built out a web app and then tried to manage tokens and rotate them and make sure the customers were doing what they should do, but you'd still have issues with things like bad players who just call your service over and over without regard to your capacity, and no ability to keep track of who's doing that without additional programming, and also no ability to keep that player from hurting your other clients. So additionally, we all know that managing our own tokens can be expensive and just as insecure as giving a function token to some users, because once somebody who doesn't like you shares it, it's out there, and if you're not rotating them regularly, it can lead to a lot of bad things. So API management lets you take all of your stuff and build out all kinds of layers of management. So what you can do is you actually start out by building your APIs. Your APIs might expose things to serve up to your customers, like products, or an API for handling orders, or you might even have a specific API for customer service requests. And once you have all of your APIs created and grouped into some sort of logical API offering, such as products or orders or customers, you can then use those within API management. And each of those products will only expose to the users who have access to those APIs what they should see. So if you only have access to the products, you wouldn't see access to the users, which can immediately give you some separation of concerns on your APIs. It's an immediate barrier. Make sure your APIs that you don't ordinarily get that in a traditional solution. And with each of these products, then you can actually go deeper and build subscriptions. And what the subscriptions can do is gives you the ability to further separate access for your users against your products. This allows you to have separate tokens for each client. So you'll have an ability to have various levels of access per subscription. You might have a premium subscription that has more ability to make more requests per hour than a standard subscription, which maybe only lets you do 10 per hour or something. You can do that with subscriptions and make sure that different players can actually pay more to get better access. Furthermore, API management also lets you use those tokens to prevent the traffic against a specific token. So you can throttle that token, and you can say any bad player who makes a request past 50 requests in a minute automatically gets denied, and it can be token specific. You can also do IP specific blocking on that level as well, depending on the API management implementation you're using. The nice thing about that is that makes sure that a bad player only hurts their own team, while other players in your system won't even notice the throttle connection. And it also makes sure you don't have to worry about the underlying architecture getting overwhelmed by denial of service by someone continually hitting your service. Now, finally, with the API management solution, you have an ability to group all of your own API implementations together. You can also offer connections to third-party API connections. And all of this has the convenience of one entry point for the user. So you have a common URL and different APIs that you can hit. As long as you have the subscription tokens that you pass along with your header to get to the products that you need, you can go ahead and call APIs within your own Azure instances or other public APIs that you need to expose, but they don't need to know what the URLs are for those. Now, additionally, with API management, you also get the ability to set this up as a configured service at Azure, which means that you can lock down all of your own functions with Active Directory and connect API management to those functions so that you have to come in through API management or an authentication token, so your functions that are exposed publicly are still locked down, which gives you a much more robust security solution. Of course, once you start building out a serverless solution, you're going to need a backbone to communicate everything that's going on between these disparate serverless microservices, right? So messaging events is going to be your backbone. This is where your serverless solutions can communicate between each other, between themselves. So the question is, which one do you use? With all these different offerings and maybe never even using them, it might be confusing what each one is for and why would you want to use one or the other. So a very simple way to think of it is if you want to use telemetry or big data, you're going to want to use the Event Hub. Now there's also an IoT Hub, which is similar to the Event Hub, but it is specifically for IoT devices, which is really awesome for streaming data from your IoT devices into your data solutions. So these hubs, both the Event Hub and the IoT Hub, are capable of taking millions of events per second. They can be used in combination with analytics services to filter the correct data that you're streaming into your warehouse, basically doing your ELTs or ETL transforms, however you want to approach it. You can set up these solutions to make sure that your data that's streaming from these event hubs, either the IoT Hub or the Event Hub, is getting filtered and transformed into your data warehouse. It's pretty awesome. The event grid is what you're going to want to use if you're going to need pub/sub traffic in your solutions. So a good example of this is you might need a Logic app or a function that responds when a user uploads a file to storage. You can create a subscription to the storage account with an event grid, and then whenever that event happens, Event Grid will publish that this event has happened, and then anyone who's subscribing, such as the Logic app or function, responds to that published event. And that's how it gets triggered. So you don't even have to do anything. As long as you have the subscription set up through the event grid, a user uploads storage, your Logic app fires. The user uploads storage, your function fires. Now, ServiceBus is going to be the choice that you're going to want to use when you're needing a messaging solution that also handles fairly large amounts of of messaging. But this is really critical for anytime you really want to have a queue, like first in, first out ordering. ServiceBus does allow that. Now, it doesn't guarantee that your messages are processed in order, but it guarantees that they have an order. So you get a guaranteed at least once delivery as well, and even transactions are available through here. So you can leverage a ServiceBus queue where your solutions send messages and can determine when and if they've been processed. So it knows the ability to know that a message has been processed as well. So Logic Apps are going to be an orchestrator for your workflow. So where functions run for about 5 minutes and generally run code, Logic Apps can run for a much longer time and orchestrate workflows. You don't even have to be good at coding to use them, but it definitely helps because there's concepts like looping and conditions that if you don't know programming might be a little foreign to you. But with the Logic Apps, looks like I got a typo on the I didn't change the title there. Sorry about that. So with Logic Apps, what you're going to see is you're going to create a number of powerful solutions, and they're really awesome. So what you generally want to think is orchestrations here. If you have a process that needs some direction, maybe integrates a few things, perhaps including transformation, data acquisition, parsing, data push operations, hitting other APIs, other Logic Apps, other Azure Functions, you can do all of that through Logic Apps. So Logic Apps are triggered with many different options available, just like functions. You can get a number of Logic Apps just by selecting a template available. So you can basically go out, say, I want to make a Logic app, and you push a button and it will trigger, it'll set up the right trigger, whether it's HTTP request or if it's an event from storage or event grid. If it's somebody tweeted something, you can actually fire a Logic app based on tweets. So if you want to follow the presidential election coming up in the Americas here in the next couple of weeks, you can simply just make a Logic app that hashtags election or something, and you get a lot of stuff, and you can pipe that over to your Cosmos database and run up a really large bill really fast. Anyway, so with all of that, Behind the scenes, what you need to know about Logic Apps is that everything is conveniently done in JSON. So this means that you can modify the Logic app through the visual designer in the portal, but you can also go in and modify the JSON directly to set things up to work. So if you have anything that's tricky or you want to see it, you could actually go into the code. There are over 200 connectors available to you. You can also create your own connectors. So there aren't many solutions that can't be orchestrated with the Logic app. You can do things as crazy as sending emails through your Office 365 connection when certain events happen. So, if you hit a threshold, fire this Logic app. The Logic app puts together a report and sends it off through an email. You can trigger other Azure Functions to run some mitigation. Whatever you need to do, you can make it happen with these orchestrators. You can, again, write data directly into a NoSQL database or a SQL database. So options are available for you. Whatever you can think of, you can likely do through a Logic app. With Logic apps, though, just remember, like functions are going to be a consumption plan. So you only pay for the execution and a minimal storage fee for the Logic app directions itself, which is very minimal. But the execution is charged by action. So if you have a very large Logic app with a lot of actions and it runs frequently, you're going to run up a bill much more quickly than if you just have a couple of actions and it only runs every once in a while. Additionally, what's very important to remember is with it being charged by action, if I'm running something like a loop, I want to make sure that I don't get stuck in an infinite loop, because an infinite loop is going to run those actions over and over again, and each action costs money, and you can see how that would be very massively detrimental to your budget very quickly. So you can also build things within that loop to execute it no more than 10 times and get out, just as a catch-all, of course. So Cosmos DB is going to be the NoSQL database of choice for Azure solutions. It provides a robust solution for you to leverage in your serverless development. With Cosmos DB, you set it up by first creating an account. And within that account, you can create one or more databases. And within each database, you create one or more containers. So you can do one account with a bunch of databases and a bunch of containers, or you can do multiple accounts with one database and some containers, depending on what your needs are. Now, each database itself can be configured for the number of request units it needs for throughput. So you can leverage that flexibility to minimize costs or ramp up your throughput on solutions with a higher demand. Of course, as you ramp up your throughput, you also ramp up the costs. So just keep that in mind. NoSQL data is highly effective at storing data that doesn't always have the same structure. So this can be useful for solutions where you might get address information, even down to the latitude and longitude of one set of data, but maybe the next customer only sends you a PO box, or didn't do any processing, so you don't have a latitude and longitude, or PO box doesn't obviously have latitude and longitude. So as long as your solutions know how to parse the data, this solution for storage gives you a great deal of flexibility. NoSQL data is also traditionally not relational. So instead of having multiple tables with normalized data, you generally get one container, contains a flat information your view or system needs. You process that and work with that information directly as if it was a view in a SQL relational database table. You're not doing the joins, they're already done ahead of time. Cosmos DB provides a data explorer at Azure as well. So you can go in there, you can drill into your data in the portal. You're able to review all the data that's in your Cosmos DB, and you can perform queries against it. So you can actually run queries to see how your containers, what data is in your containers. And there are additional APIs that you could use with NoSQL Cosmos DB. So they have APIs against MongoDB, Cassandra, a table storage API, and also Gremlin for graph databases. So you can see there's quite a bit of flexibility with what Cosmos can do for you. All right, so today we've taken time to talk through some of the serverless offerings that exist at Azure. We've seen how these offerings can give us the level of control and freedom that we need to quickly start implementing serverless solutions. We took a look at various platform as a service offerings and how that responsibility is shifted from you to Azure for a number of the infrastructure tasks. We also discussed how each of these offerings can fit into our development efforts. And as mentioned before, just remember that at Skill Me Up, we have labs and videos available on each of these technology stacks, as well as some awesome challenges. Additionally to that, we have our Skill Me Up community where we encourage you to join us because we are live there. You can communicate directly with us through Teams. We will answer your questions. We will dive into things with you. We really look forward to having that opportunity to meet you, just kind of find out where you're at, what you need to know, how we can help you. So we really appreciate if you reach out to us in the Skill Me Up community, especially if you saw something here today that you like. Don't be afraid to reach out to me. Now, of particular interest to you as well, based on the serverless challenge, serverless discussion we've had today, we do have a couple of challenges. We do offer challenges every once in a while. You'll see them on LinkedIn or maybe on Twitter, where we're allowing people to come in on a Saturday or Friday or whatever it is, excuse me, and take a day and just go through one of our challenges. So of particular interest to you might be the app modernization or app security challenges that we have. And if those are offered, you could join those. What they do is give you a number of key learning points around working with things like Azure Functions, durable functions and entities, and even the API management solutions. Of course, we have plenty to offer on other solutions like Cosmos DB, containers, Logic Apps, and messaging and event systems. And all that's available at Skill Me Up. And if you need any help with that, you can reach out to us at any time, and we'd love to help you. So thanks for taking the time to listen to the Serverless Solutions talk today. My name is Brian Gorman, and this has been a live presentation from Skill Me Up Expert Talks. So I'm not sure how to ask or see questions. Is there any questions that anyone has? All right. Well, if you do have questions, I am not seeing them here. So hopefully, if you do, reach out to me on the Skill Me Up community. I would love to interact with you and see how things are going and offer any insight I have on any of these serverless technologies. Thanks again, and have a great day.